Hi, I'm Philip. I'm going to be talking about algorithms and the introductions to those using the pseudocode and flowcharts. One of the first things we're going to look at is where does algorithms sit? So in regards to programs we're creating them, algorithms actually sit within the logic of describing a solution. They go hand in hand with the data, holding information, and its representations. One of the first things we're going to do now is define what an algorithm actually is. So here's a definition. An important thing here is that it's talking about an algorithm being a set of instructions, and those set of instructions actually solve a problem or task. And the other thing is it's in a finite number of steps, so it actually finishes. And lastly, it's unambiguous. And what that means is that it only has one meaning. So what we're trying to do is, with an algorithm, is describe a solution to a problem, and that solution only has one understanding. So that when someone else reads your algorithm, they know exactly what you have to do. Now, a good way to look at that is when we're describing algorithms in real life, things that you may have seen or used. One of them is, say, a set of instructions to put together or build some furniture. So those instructions, often though, those instructions are ambiguous. So if you ever tried to put together, say, a set of IKEA furniture, you may be a bit frustrated by the ambiguity of the instructions. Another one may be giving someone instructions of how to get to a house. So maybe if you go to Google and you're looking at getting from point A to point B, they'll give you a set of instructions about how to do that. And hopefully they're going to be reasonably clear so you'll get to the location you want to get to. The next thing is, how do you actually, for computers and for algorithms we're going to be using for programming, how do we describe those and write them down? Now, there's four ways in which we can do this. One is the Nash-Snyderman diagram. Now, they are not used for the border studies, but it is another way that sometimes people use to represent an algorithm. Another one is structured English. And the problem with structured English is they're a set of words and concepts to describe the logic, but sometimes they'll have ambiguity, or they're ambiguous because they're English, and the English sometimes has more than one meaning for words. So the two that we're going to look at is pseudocode and flowcharts. So when you're writing an algorithm in pseudocode and flowcharts, they really only have one meaning. So with algorithms, we have two ways in which we can represent the algorithm. One is flowcharts, and the other one is pseudocode. So with flowcharts, we have these symbols in which we can build up the flowchart. So the first one is a decision. So in there, what we're using that for is when we have an option, it's going to give us options from that symbol. Next one we have is a subprocess or subfunction, and that subprocess enables us to put another algorithm or another component elsewhere, and we refer to it. This is a terminator. Now, a terminator is where you have the beginning and end of your algorithm. So you'll have this as a begin, and at the bottom we'll have an end. Here we have an input and output. So these symbols are used when you're either entering the data or outputting the data. The next on the rectangle is a process. So this is where you're doing something like a calculation. And the last one is the arrow or line where you're actually connecting up each of these symbols. In pseudocode, we don't have these symbols, but what we have is we have reserved words. And typically those reserved words are in capitals. So you might have if, you might have while, and these words, by putting them in capitals, highlight that they're keywords, that they're reserved and part of the algorithm. The only other one is when you have a subprocess in pseudocode, the sub-process is actually underlined, and that underline signifies that it actually is a sub-process and that algorithm is described elsewhere. What I'm about to now do is talk about the control structures in algorithms. So these are the basic building blocks of how we construct our algorithm and then our code, our program. Now there's three main control structures: sequence, selection, and repetition. Now these three main control structures is how all your programs and algorithms are actually made up. So we're going to go through in each, and we're going to look in selection. There's actually two types of selections: a binary selection and multi-way. And in the multi-way and in repetition, there's going to be two main types we're going to look at. We're going to look at a while loop, and we're going to look at a repeat until loop. Now these two loops are used to do things when you are wanting to do something multiple times. So if you have a process you want to repeat, then you use a loop. In a selection, if you have something where you have a choice between two or more options, we're going to use the binary or multi-way selection. So these are the building blocks we're about to now describe. So the first control structure we look at is sequence. Now sequence is a series of steps that occur and you want to set them. The first one is, here's a little problem where you have a begin and end, and then we have the three steps that occur in this sequence. So what we're going to need, first of all, is we need a begin and an end. In this, we're describing a whole algorithm. So there's our begin and end, which are the same. And we're going to have a get. Now get is the parallelogram. So we have a parallelogram. We're saying get the length and height. Then we're going to have a calculation, which is a process. So we have a process. We have area is equal to the length and the height, which is what we've got. And the last thing we're going to do is we want to print the area, and here's another output. So what we have now is these three sequences of get, calculate, and display or print. Last thing we have to do is we actually have to join all these up. So we're going to be going from the first one to the next one to the third one and finally ending. So what we have is a sequence of steps one after the other, and it flows down the flowchart. The next one we're going to look at is binary selection. So another name for binary selection is an if then else. If then else selection. So with the if then else selection, you're having a decision. So in each case here, we have a condition that's going to give us a binary output. It's either going to be true or false. So here's our binary selection here. If, then, else, and if. So we have an input first. So we're just looking at a section of an algorithm, not the whole algorithm, just a section. So we have a get, which is outside the binary selection. So we have a get, and here it is, we have a get. So we get the age. Then we go into this binary selection, and so we have a decision. That decision is in a diamond. So we need to grab the diamond and put it in here. And in here, it's going to have age. Age is less than 18. So that being less than 18, it's going to either give us a true or false. So either we're going to have an age which is less than 18, such as 15, or an age which is greater than 18. So either one's going to give true or false. So what we do in here is we're coming into this age. Going off this way is if this is true. If the age is less than 18, we're going off true. If the age is false, we're going to go off to the left. So if age is less than 15, such as 18, such as 15, it's going to go off here and it's going to do the first one, which is too young. So the age is less than 18, it's going to do too young. So we grab the too young, which is here, and we're going to put that in there. If the age was over 18, it's going to do the second condition, which will be too old. So we have. Finally, what we have to do is we have one entry into this binary selection. We're going to have one exit. So these are both going to come through. So this bit here is our binary selection. So there is our binary selection, which is this section here. That's one way of doing binary selection where you've got something that's done for both true and false. Another way is when you only want the binary selection to do something if it's true. So here we have a get gender, and then we get into the binary selection. So in this case, it's checking if the gender is male. So if I check in here that our gender, that is enter, is actually equal to male, that's going to give us, mix that up, there we go. There's our gender, it's equal to male in the binary selection. Now, if that's true, we're going to go off to the right. If that's true. Now, if that's true, we want to enable the person to enter the toilet. So here's our process. In this case, what you then do is, if it's false, there actually doesn't do anything. So we're going to drop straight through. And because it's a binary selection, we're going to re-enter back into here. So what we have is, we have our data, which is priming the variable, which is then going to be used in this condition. And if it's true, it's going to go off to the right and do that process. Otherwise, it's going to fall straight through. So there is your binary selection. The next control structure is also a selection, but it's multi-way selection. So rather than having two possible options, we're going to have multiple possible options. So another name for multi-way selection is case-where selection. So in case-where or multi-way selection, we have multiple options rather than just two. So here we have the case-where. So we have again another primer, again the data. So let's get the color. So in that case, we're going to have an input. So we're going to have an input. We're going to say get color. So here's our color. So we're getting our color. Now once we have our color, we can go into the case where. So again, the color is where the decision is. We're going to have a decision color. In this case, unlike the binary where you have two options, we're going to have multiple options. In this case, we have 1, 2, 3, 4 possible options based on the color. So what we have to do is, we're going to look at those 4 cases. So the first case, when we come up to a color, in this case it's traffic lights, is we're going to have green. So if it's green, we want to proceed through the traffic lights. So we're going to proceed through the traffic lights. There we go. If the color is amber, orange, we're actually going to stop. So we're going to stop our car. There we go, we're stopping our car. If it's red, we're also going to stop the car, because you have to stop on the red signal. And lastly is, if it's otherwise, what we have to do, otherwise, which is going to capture all other situations such as the light's not working or the lights are flashing, we're going to proceed with caution. So there is our 4 cases: red, orange, green, amber, red, and otherwise. Now each of these is then going to come back in again, and we're going to link up. So with our multi-way selection, we have 1 entry into our color, 3 options, and we come through. So it's like water flowing down here. It can only go down through one way. So there is case-where selection. The last control structure we're looking at are the loops or iterations. So the first one we're going to look at is called pretest loop. Now another name for pretest loop is a while loop. We can also call it another name, which is actually called a guarded loop. Now, they're the two names that we can call a while loop. So we have a pretest loop, a while loop, or a guarded loop, and I'll explain those in a moment. So with a while loop, we have a structure where we have a condition at the top. We then have a body, or the component of the loop, and then we have where the loop ends. So we have while, condition, do the body of the loop, and then end. And we keep repeating this process until this condition is not true anymore. So to do this as a flowchart is we need a condition, in this case radius. Now while this is true, e.g. the radius we get is greater than 0, we're going to keep doing this process. So we're going to get a new radius. There we go, we get a radius. We then have to calculate the area. There we go, it's a process. And finally, we'll print out what that radius is. And so we then join these up. Now to get a loop occurring, we have to take this all the way back to just before the condition. So we now have a situation where we have a loop. So it's going back on itself. Once that's false, it then drops through. So if you think of water coming through, it goes down, does the body loop, and keeps doing this process. So there is a pretest loop. Or it's called a while loop because it's got a while. It's also called a guarded loop because the body here is tested or checked beforehand in this condition. So it's guarded. So in this case, you don't have to do the body loop if on the first time through this condition is false, it will go straight through. So the body of the loop here is executed 0 or more times. The next main control structure we have is a repeat until loop. It's a post-test loop. Now another name for a post-test loop is repeat until. Repeat until, I'll get that out in a second, repeat until loop, or it's called a unguarded loop. So there's the two names of a repeat until loop, or a post-test loop. Repeat until or unguarded. Now in a repeat until loop, the test or the condition is actually at the bottom. So in this case, the condition to stop the loop is at the very bottom. So we're going to grab one of those. In this case, we're looking at the total. I'll grab it over, and we have a total which is at the bottom. We then have two parts of the body of the loop, which is an enter, age, and a calculation. So we're looking at building a box. So what we have is a situation is, in this repeat until loop or post-test loop, the body of the loop is done first before the condition at the bottom. If the condition at the bottom is still not satisfied, it will then loop back up at the top. Once it is, it will fall through. So there's your repeat until loop. We're getting an age, like 10. That 10 is total added onto a total, which initially might be 0, so it might be 10 plus 0 is 10. We test, is 10 greater than, this should be 100. I'll make that 100. Is that 10 greater than 100? No. It's going to loop back around. And keep going to do that until we add up ages which are greater than 100, and then it'll fall through. So there is a post-test loop, also known as repeat until or unguarded loop. That's it for introduction to algorithms. I hope this has given you some understanding of the basics components of the 5 control structures we've looked at. Have a good day.